something before I leave for the weekend. But anyway, so we're nearing the end of this unit on all things exponents and logarithms, okay? And then we go into trig, all right, which happens to be my favorite. So we'll work on that. So look at your two warm-ups that we've got right here. It says, which of the following expressions is equivalent to what you see right there? 4y divided by e to the third times the square root of x, where x and y are positive constants. I think this will help with one of the ones you might have missed on the quiz yesterday, because a lot of people missed this one. Okay, what's it asking me to do? Yeah, split everything up, right? Split everything up. And so to do that, we've got division. So that's going to give me the ln of 4y minus the ln of e cubed square root of x. So I might start like that, okay? So that's the division. Now, within each of those logarithms, what do we have? We have multiplication, so we can split it again with addition. So this would give me ln of 4 plus ln of y minus, and it would be minus for both of them, so I'm going to put in parentheses, ln of e to the third plus ln of the square root of x. Well, that front two, I really can't do anything with those, but what am I going to be able to do with this ln e to the third? What's going to happen to that? Yeah, they cancel each other out. They invert each other. So I'm going to keep my ln of 4 plus my ln of y. This is just going to be a 3, okay? And then ln of square root of x, okay, what can I do with that square root? It's a 1/2 as an exponent, so I can pull it out in front. I would distribute that negative minus 1/2 ln of x, so it would be c, okay? I think the one on your quiz yesterday, you ended up with like log base 2 of 8. Right? And log base 2 of 8 simplifies, right? It's 3. All right, so I think you'll see that when you see your quiz in a little bit. Okay? So good job. You always want to simplify any logarithms that you can. If you've got an ln and an e, they will work each other out. Okay? Cancel each other out and we'll get whatever's left. The next one wants me to graph this inverse, all right, on the same coordinate plane. This too was on your quiz. Okay? When we have, how do we do that? If I have a graph and I want to graph its inverse, what needs to happen? Yeah, we're just going to switch the x's and y's and graph those points. So I'm going to start over here on the far left. That order pair is -4, -3. So I'm going to do -3, -4. So I'm just going to switch it. Okay. The next ordered pair that I see, so it coordinates, is -1, -2. So I'm going to do -2, -1, and I'm going to connect that dot, right? The next ordered pair that I can see pretty good, I want to be sure I hit it, is 0, -1. So that would be -1, 0. I'm going to connect that one. And then the next one I see is an open circle. So when I flip it, it's still going to be open, okay? So, or we could do this one, I guess, right here. I have 0, I have 1, 0, so I would do 0, 1, all right, to connect that one. And then we get to that point. So it is the point 2, 1, so I would do 1, 2, and I'd use an open circle, okay? And then that part stops connecting, okay? When we get to the next ordered pair, I have 2, 2. Well, if I invert it, it's still 2, 2. Then I have 3, 3, and then I have 4, 4. So they're just going to stay the same, and it would also be a part of the inverse. So it would look like that. Okay, so we just graph back over it. We good with that? All right, got it good with the graph yesterday. I was proud. Okay. All right, so what we're going to look about today are logarithmic function models. And that's our learning target for the day. Taking data and talking about how it's changing, how do we know it's a logarithmic function. And a lot of y'all got really close yesterday on that very, I guess it was the 13, I think, where it gave you the table and you had to decide, was it exponential or logarithmic? It was logarithmic, okay? The justification for logarithmic, all right, and that's what you have to know because that's what they're going to grade, right, is that the input values change proportionally, all right, or multiplicatively. You could have said either one of those two words, while the outputs change at equal intervals, all right, or at a constant rate, all right? Either one of those, okay? So I tried to give some spotty credit in there, right? If you chose logarithm, you got a point for that. If you got one of the justifications right, I gave you some points for that, right? So if you were just missing one piece of it, so just know that I gave you some partial credit on that as well, okay? So, but that's one of those weird things that, like, when we get ready to start really prepping for the exam, to me, justifications are one of those things you put them on a flashcard and just remind yourself, okay? It's just the easiest thing to do. All right, so let's take a look at this. It says the graph shows the average pastor's salary for various church sizes in the U.S. So we have church size down here. I'm assuming people, not square feet of the building. And then the average salary of that pastor. How is this data changing? All right, what would you say about these dots? If you were just looking at them, what would you say? Good? Okay. All right, well, would you say it's increasing or decreasing? It is increasing, I would agree. Okay. Is it increasing at a constant rate? No. Okay. So it seems to increase pretty quick at first, but then that increase kind of levels off, right? So we call that it's increasing at a decreasing rate. Okay, so it's still going up, but not as quickly as it was in the beginning. Okay, so apparently as your church gets bigger, your salary doesn't grow quite as quickly. Right? Now, just looking at this shape, it's hard to tell right here with this $40,000 dot. But what does this shape look the most like in terms of that data? Yeah, it looks the most like a logarithm, all right? Exponentials grow or decay, and our logarithms kind of do the same thing, but along that y-axis. So this is indeed a logarithm. Okay. Many people are with me on. Okay. All right. So, that being said, all right, how are we going to know that we need a logarithmic function model? All right. Well, we've already done it before with the table. All right. We would say that our inputs change proportionally. So, it's just another good reason to write that reason down. All right. Or a justification. While our outputs are equal length. Now, we're going to use the calculator if it asks me to physically come up with an equation. And this is the regression equation that we'll choose. It's a plus b times the natural log of x. Okay, a and b are constants. And b is not equal to 0. Okay. When we use the calculator, your regression model is going to be this one, LNREG. Okay. You don't want to choose LOG. There's one that says LOGREG. You don't want that one. Okay. That's what's something called a logistic curve. Right? We want the LNREG. Okay. So one of the first things it's going to lead us through, this is a pretty short lesson, is doing one where we have to generate equations and then solve for things. Okay. It's not my favorite way to do this because my calculator will just do it. All right. But it's not unlike them to ask me to generate equations. That's part of what we have to be able to do. So we're going to look at this data and generate it, and then we're going to use the calculator to do some, and then just look at, you know, all the different ways they could ask me questions. This is primarily calculator active, okay, which is good news, right? So we're going to have a good technology resource here for us. All right, so let's look at this one. So it says selected values of the logarithmic function L are given in the table above. I actually put it below so I'd have more space. Where L of x is equal to a plus b L of x. Use the given data to write two equations that can be used to find values for the constants a and b in the expression for L of x. So what we want to do is we want to take this L of x equation, okay? They gave me x values and L of x values. Yeah. Oh, it's time. Okay, yeah. Let's go. All right. If you don't want anything, you can stay right here. Okay, so you don't have to go if you don't want to. All right. We'll get our food. We'll come right back. Okay, and you can eat while we take notes. Yes. I'm going to stop the recording because nobody wants silence.
Have the silence.